Today we're going to talk about solving systems by substitution. So in the last section we talked about solving systems with graphing, and you had to be very accurate with your graphs, take some time to make some graphs, and you always had to find that exact intersection point. So not always the best way, because sometimes we're going to have solutions that are really not whole numbers and they're sitting in between decimals and fractions, so not the best way to do it. This way, though, we're going to be looking at how to use another algebraic way, solving equations and trying to use the substitution method, which is actually kind of like a twofold substitutions. Quite a few steps here, so please make sure you're writing all this down, and then we'll go through a few of them to kind of show how they actually work. So step one, what you're going to do is you're going to solve one of the equations for one of the variables. And basically what that means is that you're either going to make one of your equations y equals or x equals. Doesn't really matter which one you choose or which variable you choose, but you're going to solve one of the equations for one of the variables. Then the second step, you're going to take the expression that you just solved for and plug it into the other equation so that you now only have one variable, and then you're going to solve for that variable that's remaining. Then for step 3, now you're going to plug the solution that you got from step 2 into the first equation and solve for the second variable. And then lastly, you'll check your solution and remember to do it into both equations. To be a true solution to the system, it has to be a solution to all equations involved. So I know that's a lot of words, doesn't really mean a whole lot right now, but those are the steps we're going to keep referring back to. So here's the first example. So we want to solve by substitution for example 1. I could try graphing, I could definitely do that, but they're asking for us to do it in the substitution method. So here's how this one would look. So it doesn't matter which one I choose. I'm going to actually pick this first equation because for step 1 it says solve one of the equations for one of the variables. Well, notice how this one is already y by itself. So I don't need to solve anything. So step 1 is already solved for me. So I'm going to say there it is. There's step 1. And all I did was just bring down that equation. Then for step 2. So step 2 says plug the expression from step 1 into the other equation. What does that mean? So down here we've discovered that y is the same thing or is equal to 2x minus 4. So 2x minus 4 is the expression that we're talking about. So we're going to take this expression and plug it into the other equation. And how that looks is the initial equation is this, 7x minus 2y equals 5. What we're going to do is we're going to take the y out and plug in the 2x minus 4 in place of the y. So now I have not x and y, I have all x's in this equation. So now I can just solve for the x. I would have 7x. If I use my distributive property, I get minus 4x plus 8 equals 5. Combine my like terms to get 3x plus 8 equals 5. I would subtract 8 to get 3x equals negative 3. And then when I divide by 3, x equals negative 1. which is great, but I need to have the ordered pair. So I need the x and the y. So to have the y value, I go back into one of the equations. So this is where I go back now, plug the solution from step 2 into the first equation. So step 3 says take this equation back to the original one, and now I'm going to take the x and replace it with the -1. And now I have just numbers over here. -2 minus 4, y equals -6. So my solution is -1, -6. Now to verify that this works for both equations, I need to plug these in. And so I would need to plug them into both equations to verify. So let's just do that to verify that this works. So the step 4 says to plug it in. So y equals 2x minus 4. Well, that'll be the first one we'll plug in. The y is -6. 2 times -1 minus 4. Well, that works. -6 equals -6. So check on that one. But again, it needs to work for both. So 7x minus 2y equals 5. Plug in the x, -1, the y, which was a -6, and see if the equation works. So -7 plus 12, does that equal 5? 5 does equal 5. It checks. If they both check, now I know -1, -6 is the answer. So here's another one. I'll go through this one a little bit quicker because we kind of walked through that one a little bit slower. A lot of these just take a lot of practice to seeing how it works. So looking at these two equations, I would probably focus on this one right here. I would probably focus on this one right here for that step 1. It's a little bit closer to being solved for either x or y. And if I think about it, all I need to do is subtract 5 from both sides to get y equals 2x minus 5. So that would have been step 1. Remember, step 2 says to take this part of that equation and plug it in to the other equation. So I'm going to do 2 times x plus 3. Now I plug in the 2x minus 5 in place of the y. And it equals -3. Now I just have x's, so I can then do my distributive property. Combine my like terms. Add 15. Divide by 8. And I get 3/2 or 1.5. So from here, we talked about how we then go to step 3, and we're going to plug x equals the 1.5 back in to be able to solve for the y value. So let's go for 2x equals y plus 5. I plug the x in as the 1.5. 3 equals y plus 5. I would subtract 5 to get y equals negative 2. So based on this information, my answer, as it's always as an ordered pair, is 1.5, comma, negative 2, which would have been hard to see on a graph because you would have thought maybe it's this, maybe it's not. This is more specific and more accurate. But we still need to do our check. So number 4, check our two equations because it needs to work in both. So the first equation is 2 times x plus 3 times y has to equal negative 3. So we get 3 minus 6, negative 3 equals negative 3. So it works for the first one. And then on the second one, 2 times my x equals the y plus 5. 3 equals 3. That one checks. So that would verify that this is the solution, 1.5, comma, negative 2. And lastly, let's look at a real-life situation. We're planning a birthday party. You buy a total of 50 turkey burgers and veggie burgers for $90. You pay $2 for the turkey burgers, $1.50 for the veggie burgers. How many of each did you buy? So that's a kind of an important piece there. How many of each do you buy? So we kind of work these out. It's hard to create these equations, but basically this first equation is the number of turkey burgers is going to be our x. And the y will be the veggies. So for this first equation, we have the number of turkey burgers, x, plus the number of veggie burgers, y, equals the total number of burgers. Well, up at the top, we were told right here that we purchased 50. So there's my first equation. The second equation below, the cost per turkey burger times the number of turkey burgers is right there, plus the cost of the veggie burger each times the number of those. If I add all that up, I get the total cost, which we know is 90. So again, we now have this number to decide which do we want to go with. We can decide to turn this one into y equals or x equals, or we could turn this one into y equals or x equals. I would argue that this is the easier one for sure, to change into y or x by itself. I'm going to change it into by subtracting x from both sides, it now becomes y equals negative x plus 50. And then we can go through all the steps. This is step 1 that we just did. We made one of the equations solve for one of the variables. Then, in the second step, we're going to take this piece of the expression from the first one and plug it in where I see y's over here. So what that would look like is this. I would have 2 times x that's plugging in the y for the negative x plus 50. Now I just have x's here, so I'm going to be able to solve this for x. So I get 2x minus 1.5x plus 75 equals 90. This is going to give me 0.5x plus 75 equals 90. Subtract 75 from both sides. that equals 15. And remember, when I divide by a half, that's the same thing as multiply by 2. I get x equals 30. So then, for step 3, we take this, x's are worth 30, and now I'm going to plug it in to this equation. If x is 30, I would subtract 30 to find out that y equals 20. So typically we would say that the answer is 30, 20. But this is a real life situation. What does the 30 mean? What does the y mean? Well, up above we said that the x, or the 30, represented the number of turkey burgers. And that the y value represented the number of veggie burgers. So in a real life application, we don't want to say 30, 20. We want to add the labels to it so that it has a context. Now again, I didn't write the check out here, but basically we know that one of the equations was 50 burgers in total, 30 of one, 20 of another one. They should add up to 50, so 30 and 20 adds up to 50. Then the cost of $90. We have 30 turkey burgers at a cost of $2 each. 2 times 30 is 60. We have 20 veggie burgers at a cost of $1.50 each. $1.50 times 20 is going to be $30. $60 plus $30 is the $90. So it does check. I just didn't write that one out. But this would be the answer to this one. And again, the systems are tricky. I know there's a lot of equations. It's very important that you stay organized and neat as you work through your steps, so that you don't lose yourself and you don't make a silly mistake, which then causes things to go off. If you have any kind of questions, we'll be working on this in class this week. Please make sure you ask, and we'll be able to help you get through it.